Welcome back to the channel, guys, and hope you're enjoying the CNC build video. You'll notice here behind me that the CNC is no longer where it was originally sitting. It has been moved over to its final location. So let's take a look how I got the CNC machine finished and operational. So I've started wiring some of the wires here, the connectors on the back of this electrical cabinet. You can see across the top row there, I have all the stepper motors wired in, and I believe they're all correct. It was kind of hard to chase the wires from one end to the other, but I think I have everything correct. I'm going to go ahead and wire up all of the signals, the return signals back from the steppers to the electrical cabinet, and the spindle motor, and then hopefully I can hook this thing up to my laptop and get Mach 3 open, and maybe we can start setting up some of the parameters and see if the stepper motors will move and I can get everything to function correctly. But one thing at a time, let me start soldering all these connectors on. It's several connectors, several wires to be soldered. It is, I think it's 7 connections per connector, so it'll take me a little while to do this. But let me get started on this and see how far we get. Well, I finished the wiring for now. I have enough of the wires ran that I believe I can go ahead and start programming and see if I can get these motors to move, these stepper motors, and even the spindle motor. But I know nothing's going to move until I do some programming in Mach 3 because it is a brand new setup and nothing is programmed inside of Mach 3 to work. But let me hook my computer up to this, power it up, and start programming and see if we can get anything to work. Okay, well, after a 2 or 3 hour ordeal last night, I finally have the machine moving. And the issue was I was downloading and installing a DLL file, which is the file that communicates between Mach 3 here on the computer and the breakout board and the control panel. But the DLL file was not the correct one for this board, and it wasn't communicating. When I plugged it in, I saw the green light light up on the board, showing that it showed the connection. It just wasn't communicating at all or moving and doing anything. So I emailed the company that I purchased the kit from and asked them to email me the instructions, which came on a CD, but I don't have a CD player on my computer, so I wasn't able to open and look at them. And that package had the correct DLL file in it, so once I installed it, the machine moves. I've been doing some setting up and programming, trying to get things to work correctly, and I have some things working and some are not. Right now everything is moving. When I press the button here, the jog on the computer screen, I'm able to move the x-axis and the z-axis. But the y-axis is only working on the left-hand side. It's trying to move this motor only and not this one, so it's binding. And I'm not quite sure why. I have the This is actually A axis, so I have the A and the Y slaved together, which makes them run as one both motors run as one unit together. So I have that correct in the software, but this one is not moving for some reason. Now it has power on it because I can't turn it by hand. It's holding its position, so it is powered up, but it's possible I have something wired incorrectly. It could be the position sensors wiring. It could still be something in the software, although I don't see what it is, but I'll have to chase that issue down. But once that is working, X, Y, and Z axis will be working correctly. The spindle motor can be turned on by the controller here. If I hit run, turn the knob, spindle motor is turning. It was turning the wrong direction to begin with, and I had to switch 2 wires. This motor is basically a 3-phase motor, so on a 3-phase motor, anytime it's running the wrong direction, you can switch any 2 of the 3 wires and it'll change direction. So that's what I did here and corrected that. Let me turn this back off. Okay, but the spindle motor is only operating from the VFD controller here, and that's a programming thing. I need to find the correct settings and program it to work, and then it should be able to turn it on and off here from the Mach 3 screen, and that'll make it turn on and off and speed be coordinated by the program itself. When you're running a program, the computer will turn a spindle on and off and set the speeds correctly based on your programming, and I'll get that running here soon. I guess the next thing I'm going to do is try to sort out this issue here with this A axis and getting it run as a slave to the Y axis, so we can move the gantry back and forth, and that's a big issue, but there is a solution. I'll just have to sort it out. So let me get busy on that, and then once I have it working, we'll come back and move this thing in all 3 axes, and then we can go on to other things like limit and homing switches and e-stops and things like that. Well, after several hours of work, I finally have the machine moving in all 3 axes, and I'm going to demonstrate that. The next thing I started working on after I got it moving in all 3 axes was trying to get the spindle motor to operate from the Mach 3 desktop, and I haven't sorted that out completely yet. I think I'm on the right track. I had to order a little electronic component to step the voltage down from 12 volts to 10 volts. The input on the card is supposed to be 10 volts in. I'm not sure if 12 would work or not. I can't see a reason it wouldn't, but since it says it needed 10 volts in, I've bought a little electronic device to step the voltage down from 12 volts to 10 volts, and it'll be here tomorrow. But in the meantime, let me demonstrate these 3 axes, and then I'm going to get to work on working on wiring the limit switches and homing switches. That's the next thing on my list. But let me show you this machine moving, and this is moving at 50% speed so far. So one problem at a time. Finally got the computer communicating with the breakout board, so that was working, and then I finally got all 3 axes working correctly, and I tried to get the spindle motor to work and ran into a bug on that, so we're going to move on until that voltage limiter comes in tomorrow. The next thing I'm going to do is work on the limit switches. I need to figure out exactly how this card works as far as reading the inputs, and then start wiring in the different limit switches to the board and figuring out how to program that correctly. So let me get started doing that. Well, after way too many hours working on the wiring of these inputs and outputs, I finally have all of the inputs working, and the inputs are the limit switches, homing switches, the e-stops, I have 2 e-stops, and the tool 0, which is this. It'll be mounted up here somewhere. When you do a tool change, there's a button you can press to auto 0, and it'll come down until it touches and makes this switch, and it'll calculate the distance down to the surface of the spoil board and automatically program that in. So every time you put a new tool in, it'll program 0. And I have all of those working. It just took me a while. The wiring took me a while to figure out and get right, and then the programming also, but I finally have them working. That is a huge relief. The only thing left well, there's 2 things left that I need to do. One is I need to make mounts for the limit switches here on the Z-axis. I put that off till everything was running motorized up and down, and now that the steppers are moving the Z-axis, I can put the limit switches on. I know where it stops up and down. This is the up limit here, or just before it. So I need to make 2 mounts, mount those switches, wire those, so I have those limits complete. And then I need to figure out what it takes to get the spindle motor running off of the drive down here. I had to add some components in. I just had them kind of stuck in right now with foam tape. I have, this is a voltage regulator, and this is a 2-channel relay. There's 2 relays, one for forward and one for backwards. But I haven't got that wired up and working quite yet. It's a matter of wiring, programming this VFD drive correctly. There's a lot of programming, different signals and things it does to switch it over from being usable on the front panel here to being usable in Mach 3. I've changed some of those and wired some of it, but I don't have it working yet. That is one thing I'll have to figure out. I don't know quite what I'm doing. I thought I did, but it's just not working when I thought it would. But haven't given up. I'll get it working eventually. But I guess for now, let me go ahead and make some limit switch mounts and get these 2 Z-axis limits up and down mounted, wired, and functioning, and then we'll come back and try to get this spindle motor working. And then once all of that is done, I believe we can go ahead and close up our electrical box here, start mounting our MDF board on here, our spoil board, and then move on to some more programming, calibrating, and getting everything correct and ready to use. But let me get started on those limit switch mounts, and I'll see you guys in a minute. Okay, I want to give you guys a little update, or a couple of updates. First, we'll start off with a simple thing. I have finished with the Z-axis limit switches. Here is one. I'm using this bolt as the stop. This proximity switch will pick up the head of the bolt, and I can adjust it up and down and in and out and get that precisely where I want it. This is the up limit switch here, and it is picking up the top here of the Z-axis. So when that comes up, I believe both of those will work fine. The other update is, it has been 2 weeks since I published a video today, and it's time for another video, but I don't have a lot to tell you guys. I've been working for several days trying to get the last little couple of details working correctly, programming here on this breakout board, and I have finally given up. I cannot get this to work. There's the instructions that came with it are very vague, and they have nothing covering the issues that I can't get to work in the instructions, and there is no technical support dealing with this company in China because I basically bought the parts through a broker and not directly from the factory, so they don't give me anything but generic answers when I ask questions. So I had a couple people recommend, even when I started this, that I trash the Chinese breakout board. Let me show you that. Climb under here. This is the breakout board, which communicates between the computer and everything else here. And I have decided to scrap this breakout board and buy an American-made one. There are a few on the internet that are very popular with people. And the one I chose, I'll show you when it comes in. It should be here in a couple of more days. It has full instructions on the internet, lots of support, videos, and feedback from user groups and things that I can use to help program it and get it working correctly. So I'm at a standstill right now. I had hoped to have this thing finished and working, but I spent so many days trying to get this figured out and doing what I need it to do. I can't get it to work with the spindle motor and start and stop it from Mach 3. And I can't even get the MPG handset here to communicate and function correctly, although it was part of the kit. And I have tried everything that I know how to do, reading and watching videos and trying different things, and I have just given up. I just can't make it work. So I should be able to do this with ease with this American board once it comes in. So we are just waiting on that to arrive. I believe it'll be here in either 2 or 3 more days. Then I can install that and wrap this up and hopefully get this machine running. I am off work all next week, so I should have plenty of time to finish this and wrap it up and get a video published for you guys to see. So hopefully when you watch this next video, the machine will be running by then, or at least very close. But that's an update, and I'll keep you guys posted once this new breakout board comes in. Okay guys, here's an update. It's been several days since I've actually videoed, but I was having trouble getting the spindle motor here to function from Mach 3 desktop, and I was struggling with this Chinese-made breakout board that came with my kit for the stepper motors and drivers and stuff like that, and I could never get this board to work, and there was just no instructions, or very minimum instructions, and no technical support at all. So I finally gave up and bought a different breakout board. You can see here I bought this one. Anyone that's in the CNC world will recognize this. This is a very popular board that is sold by Builder CNC. And it has great support, lots of online videos to teach you how to install it and program it and run it. And I purchased this, ordered it. It took 4 days to come. I ordered it 3-day shipping, but it was delayed and lost. It finally came in. I have wired this in and have everything wired in correctly for the spindle motor to work. Now what I had to do was I had to add this variable output resistor. This steps down to 36 volts coming out of the power supplies to 24 volts, which is what is needed to power everything else. This 24 volts powers the breakout board, the sensors, the proximity sensors, and the relays here to activate the spindle motor. I have a dual channel or a 2-channel relay board here, and one of these relays is for forward and one of them is for reverse. Now most people would never use reverse, but I'm hoping to install a tool changer in the near future. I have found a tool changer that works great for this type of spindle and head, and I'll probably show you something about that here in the future. But for now I just wanted this spindle motor to operate in forward and reverse, and these 2 relays do that. One relay activates forward and one activates reverse, which is pretty simple. But I've wired this in, programmed it, and finally got it functioning, and this is how it works. When you come here to Mach 3, I have you plug in your spindle speed, which in the cut program, this is done from the cut file automatically, but here I've typed in 5,000 RPMs. And to test this, I come up here and click on the spindle activate. You can see the spindle motor is turning, and to vary the speed, you can speed it up and slow it down here with a click the button again, it turns the spindle off. So this is functioning in both forward and reverse like it should. Everything is great with this. I'm happy to finally get this finished. It's taken me about 2 weeks to get this going. Well, my SD card was full and I didn't realize it, so I lost part of that video. But I did install this MPG here, programmed it, I have it functioning. I still need to do some programming on the CNC. There's quite a bit of programming to get things dialed in exactly the way I want them. But from a functionality standpoint, everything is working. So I think I am finished with building per se. But the next thing I'm going to do is move this finished CNC machine over here against the wall where it's going to live permanently. I need to clean out an area here where I can get it through there, take it over against the wall, set it where it's going to stay, and then level the frame with a laser level or digital level and get everything perfect with the adjustable feet. And then once it is sitting where I want it and level completely, I will go ahead and lay this wooden deck that I have made here up on top of the machine. And if I have enough fasteners here, I'll go ahead and install it, but I may have to order some fasteners. It's going to take quite a few, and I'm not sure how many I have left over. But either way, I'll be able to lay the wood up there, and once this is completely in the position and assembled, we can start doing some of the detailing work like tramming the head. Need to tram the Z-axis to where it's perfectly perpendicular to the tabletop in both planes, adjusting motor speeds, and dialing everything in to get it just exactly right. There's a couple of other little things. I still need a metal table here for my computer to sit on with a hole to mount this e-stop. And then once the tabletop is on and secured permanently, I'll have to mount this over here in the corner somewhere where when I do a tool change, I can come up and touch off and zero on this. Also need to install the script to get this to work and run properly, so when it touches it, it knows to auto zero to the tabletop. But still some things left to do, but let's go ahead and get this area cleaned out, move this table over here and level it, and then we will start working from there. Okay, I want to show you this MPG here. To use this, you hold the button in to activate it, and then you can select X, Y, or Z axis. This is X. Go to Y. And then Z. And the speed is incremental also. You can do it to 10 times faster or 100 times faster, but those two are too fast because I haven't adjusted the top motor speed yet. There's also an e-stop button here that I can press if anything goes wrong to stop it. It is wired in series with the other two e-stops, so pressing any e-stop does the same thing. But that's how this MPG works, and it is working like it should. And I have calibrated the machine. Let me show you how I calibrated this. I put this small end mill in the machine and I plunged a hole here. And basically what you do is once you plunge that hole to calibrate it, there's a setting in Mach 3 that you pick each axis. We start with X and we tell it, the machine asks you how far do you want it to move, and I said 12 inches. So it moves over what it thinks 12 inches is. You measure how far it actually moved, plug that distance in, and it compensates the math, the steps per revolution, I think is what it changes, and adjusts to make it 12 inches. Once I did that and knew that it was close, I came back to the same exact spot and I told it to move 36 inches. And then I measured and readjusted again. And the reason I do it as far as I can across and then compensate is because if you were off, let's say you moved an inch, if you measured and you were off 10 thousandths here, well, every inch it moves you'll be off 10 thousandths, so by the time you get to the other side of the machine you're off quite a bit. But if I move all the way across as far as I can move the machine and I'm off 10 thousandths, then that's not quite as big a deal. So I know all three axes are relatively close. The next thing we need to do is put a piece on here, like a piece of wood, and usually program to cut a piece. Let's say we cut a 5 or 6 inch square, and then we come in the middle and we plunge a hole a ½ an inch deep. So once that piece is cut, we can come in with the calipers and take measurements and see how close it actually is. Am I actually off on that 5 or 6 inch square? Is it off 5 thousandths, 10 thousandths, whatever? Then we can plug that dimension into the computer and be completely accurate. It'll be down to at least 1,000th. So that's how you calibrate the machine. That part is finished, and I set up some of the limit and homing switches. So that is done. The next thing I need to do is I'm going to take this bit, I'm going to plunge a series of holes through the entire table. I have some threaded inserts ordered. It'll be here tomorrow, and we will run those threaded inserts up through the bottom of the wood. That will be for our clamps that we use to hold down our material we're cutting, be it wood or metal or whatever. But once I have that series of holes in, I can clamp a board down to the table and hold it still, and then we can start doing some cutting and tramming in the head and making sure it's perfectly square. Now I set a level up on this head, just on the outside surface, to make sure that it was as close as I can get it for now. And before I plunge these holes, I know that they're pretty doggone close to perpendicular to the surface. But once we can clamp a piece of material down and actually do some cutting with a wide bit, then we can tram it in perfect with that. But this will be close enough to plunge this series of holes. So let's get started doing that. Okay, we have all of our holes drilled for our clamp features. You can see everything here is perfectly in alignment. Well, except for that hole. There's always that one guy. I somehow messed up. I think I was about an inch off here. But I may come back later and put one here also, or just leave that. It doesn't really matter. But I have these spaced apart. They're 40 inches from hole to hole, which is about the travel of the x-axis. That's about the limit, is 40 inches. And then I'm down this direction as far as I can go. That's the limit of the travel here also. So I have part of the table I can't use, considering if I add a tool changer, I may put it here on this section and then have it motorized to come out, do the tool change, and then retract back out of the way. But hopefully that won't be dead space. I'm thinking that's what I'll do with the tool changer in the future. I also added this vacuum head here. This is the one I had showed you in a previous video that I borrowed from someone's YouTube channel, and I can't remember whose it was. If you see this video and it's your design, let me know. Be glad to give you credit for it. I did modify it slightly. He had a file online you could download, but I just kind of looked at some measurements and recreated my own, but it is based on his design. I had to add a flat here for clearance on this. Everything is attached with magnets, neodymium magnets, so this removes, just popping it off of magnets, and both of these for easy tool changes. I need to order some more of these bristles. I thought I had enough to do this, but that is all I have left. So I'll get some of those on order. And I also need to fasten this in a couple of places here, just to keep it managed when it runs up and down. I've attached it here overhead. Okay, so we cut our test piece. This piece is supposed to be a 4-inch square with a 1-inch hole in the center. We'll measure it. All three axes should be off the same amount. Showing 4 inches and 40 thousandths, so we're 40 thousandths over. It'd be better to do this at same here, about actually 41 thousandths. Let me try this again. And this one's showing 41 also. So we are oversized by 41 thousandths. So I can go in on the calibration screen and tell it 4 inches, and when it asks me how far it actually moved, I'll put in 4 inches and 40 thousandths, and it can compensate and adjust all three axes to be correct. And then our setup procedures should be finished for now. Well, that's going to be about it for this week's video. I mean, other than a few little tiny details like putting the threaded inserts into table for clamps, and testing this Z-axis script, which I'll do once I surface the table. And we will surface the table once the fly cutter comes in here. I think it's 2 more days before it shows up. But the new CNC seems to be working good. Everything is calibrated now. All the limit switches, homing switches, the calibration for the inches that the table's moving are all finished. And we are close to using this, so I hope to be cutting files again in the next 2 or 3 days. But hope you enjoyed this video and the CNC build, and now it is time to get back to building the Supercar. So I'll see you guys again in a couple of weeks.